What's up, guys? An interview of your girlfriend like Clement? No. Favorite CP streamer? Thank you. Final Gaussian Elimination? Yeah, we'll see. So definitely I want to do something to prepare for lectures, and one possibility is that it will be Gaussian Elimination, but I feel that I postponed it so long because I just think that I can easily mess it up and it's not easy to talk about precision. So I'm also considering a possibility that the next lecture to make will not be Gaussian elimination, but instead something else. But that's up to us. Like, we will decide. Maybe I will do some poll. So it's not that I planned well what I will do today, but we need to do some progress towards making a lecture. CSES geometry problem stream. I'm happy you like that. Radio so bad. Do you have a Twitch channel? Stream by schedule. I mean, normally on this day, on Tuesday, I do hard color problems. So today it's a little bit different. All right, what do we want to do? I already made some preparation for a Gaussian lecture, right? What is this from a year ago? I guess I did some research on resources on that. This drawing on the left suggests something completely different from Gauss. Rate my Discord. Oh. So you mean that you will spam my Discord? Why? Just why? All right. This thing from 9 months ago. So what did I do here? Going live. Oh, that's almost 6 hours. Search for the pivoting element. All right, this is the lecture when I did spend a lot of time on Gauss. Did I make some notes? If yes, they will be on GitHub. And there is FAQ. Right, so wait, I'm banning some people from the chat. All right, done. There are notes on the right. Gaussian elimination. Pronounced with S, not sh. I used to say Gaussian or something like that. So a system of 2 free equations talk about matrix. Translate to English. So apparently I have access to some PDF in Polish. I thought that I already made a particular list of multiple problems with some order. You got a job thanks to my videos? Nomatic, that's amazing. Congrats. How frequent is this topic? I don't know. Moderately frequent. So this is done. I already made a video on computations modulo P. This is not done. Solve a system of 2 equations, 3 equations. Talk about matrix. General algorithm. If I decide to continue with that, I will just today open Polygon and start working on problems. I need to log into Overleaf to see what's going on here. All right, I have something. I see, this is in Polish. Let's download this. This was a series of problems, but they were not perfect. XOR maximization, yeah, sure. So we have some collection of problems. I considered them last time, and I remember that I thought that I made a list of problems that I want to do, didn't I? Competitive programming free book, probably you can use it for something. It's not that I lack, I know how to explain it, I think. I thought that I already made a list of problems, particular problems that I want to create. Trapezoidal map by Herf, I don't know what that is. Right, we need to go through this. System of 2 free matrix representation, show a general algorithm. Precision issues pivot. Binary version. Here they talk about how to really implement it and what are the generate cases. Does the answer always exist modulo P? Right. Stable graph. Oh, this was the messed up problem where incorrect solution passes or something like that. Or actually the intended solution isn't correct. Prepare directed graph random walk on polygon. Right. Famous algorithm for point location. I never heard that name. Maybe I did, but for sure I didn't hear a name. Gaussian elimination problems on catis. I don't need complicated problems. I want good problems to teach people with them. Right, so link. We don't have a link. And today, what are we doing today? We are preparing a lecture on Gaussian elimination. Maybe some different algorithm. Choose problems. Good, easy problems. All right. Alright, I'm sure that binary version isn't the best first choice. I think that the first problem would be just real value version with very small values, like n up to 5, all the values are up to 5, it's guaranteed that there is exactly one solution. The same thing modulo mod, and you need to say how many answers there are, and only then binary version where you need to be fast. Makes sense. So in binary version it will be like million values, each of magnitude 2 to 60. Binary search remove the playlist queue question after your last stream. Oh, why? Why did they remove it? During the last stream I solved a problem on binarysearch.com and apparently now they removed it. It was hard, but it wasn't wrong. Yeah, I'm sure that there won't be a lack of hard problems. Like even on code forces already, I don't need to prepare them. They are already there. So it's not... The main point is to create/choose good, easy problems. High qualified. Before I move on, I need to decrease the font of chats. Actually, do I need to do that? Yeah, whatever. I don't need to do it. Let's edit this. So first, and n and I of ij up to 5 or even smaller. No, up to 5. This is real values, single solution guaranteed, n and absolute value of aij is up to 5 or just very small. Then the next problem will be modulo prime, and then third problem is binary version and up to 10 to 6th or so, and every AI is up to 10 to 18. Maybe find max XOR or something like that. Those are 3 important educational problems. And then there are a lot of hard problems where we need binary stuff. There was also something with segment tree, generally things from this list. I think Ivan and Burgers was related to segment tree. XOR maximization is just SPOI problem, but we can, so we can take it. This was a bad problem, I think. Snakes and ladders. Oh. Advanced proceed. It was this, where it's more real life when you need to create a directed graph out of it. Instead of it, I think it's better to just create a general problem where you're given a directed graph. This is a long problem where there's some unnecessary stuff. Are you going to make own problems on this topic? Yes, at least some of them. It's not that time consuming to create easy problems. While it is very beneficial, I think, for any new topic when you want to learn it, to first see some easy problems. All right, and one possibility is to indeed go with Gaussian elimination. Or as I told you at the beginning of a stream, I think that I'm postponing it because it's not a very simple and small topic, and I'm also considering doing something else instead. But I guess if we already spent so much time here, then let's just do this. By so much time, I mean this previous lecture, our previous research stream, where I spent 6 hours on it. Maybe here some part of that is just absolving stuff. Oh yeah, this is a not-coder problem. Then I will just assume that whatever I got from the stream are those nodes. Right, any thoughts, suggestions, chat? We have 3 very educational problems. And is there anything else? We can create something with real values where for sure you need to choose a pivot. But I'm not sure if that's necessary. No, instead of that, I will create a problem with directed graph random walk, where if you don't choose a pivot, you will get wrong answer. Is that a good idea? Maybe. But I don't know what limit to choose there, so I could say that the internet solution for sure works. What about making this problem but with modulo value? Then we get back to the question, does the answer always exist modulo p? For any set of equations, if in the real values there is a solution, I believe it is rational, like x divided by y, then solution modulo p exists maybe if and only if y is not divisible by p. Is that it? But also if x is 0 or it's divisible by p, maybe we will incorrectly say what's the number of solutions. I think that's possible. So how can we guarantee that? I can just, I guess, ask on Code Forces or any other forum. Do I need to watch the last algorithmic research stream? No, you don't. It was so long ago that I don't remember what was there. I'm just looking at these notes. By the way, this is linked to notes. Did I close it? Yes, I closed it. A link. Not to edit. And I didn't want to Google it. Yeah, this will work. Link. Here you go, chat. Snakes, I don't want it. What do we have here? Given a set of numbers, all up to billion, Adam discards some numbers, then Bob discards some other numbers, but he cannot discard all of them. Then they play NIM game. Adam starts. How many at least numbers must Adam discard so that he would for sure win with Bartek? Alright, then we just need to find the base of this. I don't think this problem is worth it to prepare it. Well, actually it's easy anyway, so maybe. But should it be a separate problem over this one? Find max XOR. I guess if we prepare them both, then one of them can have very high limits and the other would not have high limits. Hi Proxy King. I guess let's just start preparing problems. No, I want to decide how we need to implement Gaussian elimination. Let's do this. How not to get stuck at division 2b? Practice more division 2b problems. So, alright, how do we implement Gaussian elimination? Let's try something. I will implement it myself, then I will look up other implementations. Let's do it with real values. Why do you want to raid my Discord server? All right. I will maybe put some information on the screen. So what I'm doing now is implementing Gaussian elimination on real values. All right. Password is admin1? No. It was 5 characters, so it could be only admin. Yeah, my password to PC, because I'm right now with my PC, is weaker than any other password I have, but it's not admin. Password to my, for example, notebook, laptop is stronger than that. Because for you to get access to my PC, you actually need to be here. While laptop, it's more likely that I will lose it. I don't know, I will be somewhere. User 1, pass 1. Good ideas. Close. All right. Do we need a struct? I guess we just have two-dimensional array. Will I swap sometimes 2 rows? Let's work with an example. Like 2 times x plus 5 times y is equal minus 3, and 4 times x minus 4 times y is equal 1. All right. Here n is 2, but in general it will be not that easy. Create something of size n by n plus 1, and I guess just here fill it. 2, 5 minus 3, 4 minus 4, 1. I'm just solving this system of equations. We'll get some solution and we'll see if it works. Magic potion to increase problem solving rating. Yeah. Indeed, it's not a video game. Like, there is no magic potion. You need to practice programming or competitive programming for a few years, and then you will solve problems more efficiently. Now, for every next column, we are looking for any non-zero unless it's a row that is already used. So if in some row we already got some non-zero on the left, we need to skip it. Used row of size n. if not used row, and this value is not 0, then we say best row is row. Actually, I will do something else later. I will choose, as pivot, we need to choose value with biggest absolute value. Best row is -1. Right. In this case, continue. But otherwise, we need to say that this row is used. I'm not, by the way, I'm not doing a lecture right now. I'm just preparing myself for a lecture. I didn't implement Gaussian elimination for many months, or maybe even years. I know how to do it, I know the algorithm. I just want to get a nice implementation that I can teach. Right, now if I have some value here, I need to make, in this column, I need to make all other values equal to 0. All right, now what's very important is value. There is A of best row and column. Let's say that this is 3, and let's say that I'm now looking at this value 7. Then I need to subtract, I need to say this minus equal this multiplied by 7 over 3. So the ratio is that, like 7 over 3. And the whole row needs to be subtracted with this ratio. My phone is calling. I am back. Right, so the whole row we subtract from the other row with proper multiplier. The multiplier is ratio. And I think that's it. We will get now simplified grid. Ratio not declared, y is 0. So this is a function that is hard to get right, because here you deal with precision issues. If a value is very close to 0, do you say it's 0 or not really? Like, you need to decide about some epsilon. Column. We go through the main column. This is fine, but then C2, C2, C2. The naming could be better. Ratio. Nothing happened. Nothing at all. 2, 5 minus 3. Yeah, really nothing changed. Will you consider elimination on modulo 2? Yes, yes, that's a very important part of the lecture. Usually Gaussian implementation is done in parallel. I don't know how to do it in parallel, but I guess it's quite easy. All the small stuff like this one, this can be done easily in parallel. I never implemented it in parallel. I can imagine a case where you need to solve a big system of equations and you need to run it parallel, but for sure it's not usual to do it this way. print the column and best row. It seems that it will be -1. Yes, it's always -1. Not able to find anything. Oh, is0 should say that it's smaller than epsilon. Right, we got something. Apart from this, I can already see what's x and y. Y is so here I assume that this means exactly that. This would mean 7 times y is -3, so y is -3 divided by 7, and x is 1 divided by 4, so 0.25. And now we can analyze if this matches that. I don't think so. I don't think so, because this doesn't work. For x being 0.25, oh, n+1. Yeah, we go through the whole grid. The last column is n. Now it's a little bit different. 7y is equal to -3.5, so y is -half. Does it work now? This is 1 plus 2, yeah, that's 3. Oh, but x is minus this. Right, then we have -1 plus 2, that's 1 indeed. And here -half minus 2.5. Right, okay, this is a proper solution. But now that we have this, how do we get proper x and y? I need to go from right to left. Here it's not that hard, because I will say that there is some solution. Go through the whole grid. If this is non-zero, so you're seeing a value like here, there is 7. This is in column corresponding to variable y. Then I know what y needs to be. This is like from here. If 7 times y is this, then y is this divided by 7. -1/4 and -half. All right. But it isn't always that nice. Though if there is exactly one solution, maybe it is exactly that nice. Somebody is cursing me in CP server. Ask them what I did to them. Do you think you would solve system of equations if you didn't know Gaussian elimination? Sure thing, like system of 2 equations like this one. You learned that in middle school, right? It's not hard math to do this. You can also, I guess, figure this out for some bigger size of this. Are you asking if I would be able to implement a solution without knowing Gaussian elimination? I'm not sure about that. Easier in Python. The point isn't to teach people how to use some library. If I implement here anything, I can just tell people to copy paste this code. It will be like using inbuilt library. The point is to teach people how to implement this algorithm, and then also you know how to modify it. That's the difference between just applying functions from library and implementing it yourself. In the latter case, it means that you understand it and you know how to use it in non-trivial cases. n equations, I don't think I would be able to implement it without knowing Gaussian elimination, because you basically need to do Gaussian elimination. Right, let's try some bigger example. Also, what happens if I make something redundant, like 4 times y is minus 2. Oh, but then I need to modify this whole thing. Anyway, this is good enough to solve the first problem that we discussed. Just, we need to read the input. Let's read the input. We have this, then n is equal to 2, and we have 2, 5 minus 3, 4 minus 4, 1. Last number in every row represents the constant. This row means twice x plus 5 times y is equal to minus 3. Alright, and now let's make it bigger. Like this. I got something. We can check it in Wolfram Alpha. I hope that this works. And the last equation, 2x plus 0 plus 2z, is this. X is 77, y is 206, and z is 392. Good. Now, what happens if I repeat some equation? Let's get back to this, and let's say that here we have the previous one just doubled. We had here 0, 0, and this is some bullshit answer, because here I assume that the whole row is of form zeros and a single non-zero value. Well, it makes sense. I assume that there is a single solution. But if there is a single solution, will this algorithm always work? I think so. I don't see any issue, other than, of course, I need to improve it by choosing pivot properly. What is Wolfram Alpha? A very smart calculator. Let's try to test it with bigger data. What if here I say that I choose a random value, I got something. Here there are a lot of zeros. In this previous test I got some 10 to minus 15th. How can I measure the mistake? When I have final answer, I can go through the initial grid. So remember memo equations. And here I can check if this is right. For every row, I can check if this equation is fine. Sum is 0. Go through all the first n columns, so those with variables. If you see 7 times x, just add 7 times x. Memo equations, answer of column. And this should be equal to the last number. So add it with minus that number. It should be 0. If this is not 0, it means we are not precise enough. Those are zeros with good enough precision. How many zeros are there? Around 12. That's still fine. I can just print the biggest out of those mistakes. Biggest error. What do you want? Error. Right. And not in. If n is 50 and I choose random values, then mistake is around 10 to minus 10. But what if I choose bigger values? Oh, okay, then for 10 it works, for 15 it works, 20, 25, but for 30 the mistake becomes infinity, because then apparently this precision here is not enough. Maybe I should decrease or increase this epsilon. But I also expect some huge values here. Maybe that's something important in this lecture. I need to just show this code. Let's try it on random values and let's see what's the mistake we have. Please explain the general idea for this method in short. Actually, I can do that. So instead of now implementing, let's do summary on this algorithm. Right, what is Gaussian elimination? When you have a system of equations, like let's say 3 times x plus twice y minus 5z is 17, and some more equations. Sometimes there will be 0 here, which means that this term doesn't exist. Like its multiplier is 0 already. And here, always, when there is no multiplier, it is like 1. How to solve this system of equations? We go column by column, and in every next column we find any non-zero, and we try to get rid of everything else in this column. When we solve system of equations, we can add or subtract two equations, or we can also say 1 minus equal the other times something. Here, if this equation is true, then also I can multiply it by 1.1 and I will get this 1.5 times z, it's 1.5, and now I could add those two together and I will get 2y minus 3.5z is equal to 18.5. With that I can forget about this partial thing and about this one. And I repeat the same for this equation. Also, I properly multiply it here by 3 and then subtract from this thing. and I will get something from this. I don't want to do the math, but let's say we get 5y minus 6z is equal 100. That's not true, but let's say so. And now we got system of three equations where only the first one has some x and everything else has 0 next to x. Now we have system of three equations, and now we focus on the second column. This row is kind of already used, and we then, in the second column, so next to y's, this is second column, we are looking for any non-zero, so we can choose either this one or this one. Well, this one works. And now, using this equation, we need to change everything else in this column to 0. So yeah, we do it same way. That's what Gaussian algorithm does. To improve the precision, we should always here in this column choose the biggest value. I mean, the absolute value should be biggest. That's best for precision, otherwise numbers grow a lot. Let's experiment with this now. This is Gauss. This is Gauss precise. Where is this? Best row. Here. If this and non-zero, and best row is -1, or this guy is greater than the previous one I have. This chooses biggest by pivot, so greatest pivot. The answers should be the same. Those are the answers. Actually, I don't want to see anything else. Why still I see so much stuff? Oh, I didn't want to close it. I don't want to print you. Oh, I'm only modifying Gauss precise, and I want to modify Gauss. The answers we got are the same, and then this is the error we have. Here it's roughly the same. Now let's try both on 10. Still, the difference isn't a lot. Well, this one is 10 times better. Let's try 20. Again, this one is like 20 times better or so. Exactly 10 times better, so it's just better. And this is an example where the normal Gauss, where you don't care about pivot, just stops working completely, and the mistake is billions or billions of billions, and here it's still precise enough. But precise Gauss will still fail if I increase this a little bit, right? 40. It's looking strong. 50, 60, 100. Nice. Okay, up to 150. It worked. So that's very nice. So if you don't care about pivot, it will stop working at n equal to 30 for random values, while here, or maybe I should modify this a little bit. I should see what happens if I change this to bigger value as well. Maybe I have some ties and there are multiple solutions. And then I'll also modify that. I don't know why I modified this in codes instead of creating some generator. Right, but let's try this again. Oh, then I increased values and already for 20 the standard Gauss stops working. Maybe I should then modify this. I'm modifying Gauss precise. All right, it works. I know what is some other metric that we can do. We can see what's the biggest partial value we encounter. Because if you deal with big values, the harder it is for you to get good precision. Yeah, I think that's a good idea. Is this representable as dynamic programming in terms of solution with one less equations and one less variable? You can think about it like that. So you see here, when we go to second column, it's not that we fully forget about the first equation. And so not really. But you can think about it like this. We solve this, from this you will get y and z, and then you can plug those values of y and z here to the previous equation. If you think about it like that, then yes, it is dynamic programming. But I don't think it helps at all to say that this is DP. Where exactly does Gaussian elimination get used for? In solving systems of equations, algebraic equations like this one, which, for example, appears often in geometry, but also in randomistic games. All right, so I want a generator instead of doing this bullshit. Do I have a generator here? I do. We take n from the input, we print n. Also, I will take some kind of max from the input, what the values are limited by. And right now we have integers in the input. Is it good? Is it bad? Should I give real values in the input? Shouldn't matter. I will give real values in the input. So there is a whole row of size n+1 for every value generated from minus max to plus max, then print. Generate with n equal to 3 and values up to 1000. Alright, this seems to work. Still, right now I have integers, but I will later change it. So let's change this to really reading the input. And as I said, let's get the biggest partial value. Initially big is 0. If we get something like 10 to 18th power, it means that we don't stand a chance to make our program precise enough. Gauss precise. So here same logic. After this. I will change information on what I'm doing, comparing two different iterations of Gaussian elimination. Gauss precise. Here both are around 500. 330, 1800, that's some progress. 200,000, 6,000. Okay, it's getting better, at least for random inputs. For the worst case input, actually, it's a different story. But I guess we see the issue here. Gauss precise is able to keep all values to be kind of small. It's here around 1 million and here around 1 billion. Actually, I'm surprised that here Gauss worked. It stopped working. Maybe better epsilon would work. Also, now that we choose pivot, do I need to use epsilon? I think I don't. All right, next thing is maybe we'll later get back to comparing those two different implementations, like which one is better. Well, we know that this one is better with pivot, but how much better and how to show it best when making a lecture on this topic. Can I get rid of function is 0 in Gauss precise? I think I can. So because we choose the biggest pivot by absolute value, this should be non-zero. Here I will say assert that this is not -1, and this assert is optional, but a of best row column, it shouldn't be 0. Do we ever use this? All right, now when retrieving the answer, is it best now to just look for non-zeros? I know what is a good other problem. No. I closed all the tabs. Oh, because I'm in virtual machine now. While this is a good easy problem, maybe we should make something where there can be multiple solutions and you need to find any of them. Count solutions. 0, 1 or more. Then real values, maybe count solutions, 0, 1 or more, and print any solution. Or maybe any non-zero solution, so that you would really, like, every value would be required not to be 0 or something like that. I think it will be hard to make proper tests for this. With this I mean that sometimes you will be left with an equation like this one, like 2x plus 3y is equal to 10, and there are multiple solutions here. And maybe then the next equation is just z is equal to 5, right? And you can say that, for example, x is 5, y is 0, z is 5. There are more possibilities here. Like with real values, there are infinitely many possibilities here. Now I think it's time to see implementation made by others. First I will, no, now first this thing. So is 0. When I find, for every column I find the row, then I can save it. Which row for column is best row? Every column, and then for every column, so let's call it column. When possible, it's good to avoid I to make variable names more meaningful. A row is which row of column. Now I assume that this is non-zero, and answer of for this column, so for this variable, is what? 5x is equal to 10, then 10 divided by that. All right, we have a of this row, and oh, basically it's just this line. I think nothing changed. We got this exactly the same. I think cool. And so now I don't use a is 0 at all, other than in an assert. Cool. And by assert I mean this. This is still kind of is 0. If I'm guaranteed that there is exactly one solution. If there are many, then that's a different story, and sometimes we will not be able to do this. All right, now, do I ever need to swap rows around? I don't think so. This mapping of for every column where I am, like here, did I make a new slide or what? Yeah. This information about the blue circles, this is what I keep in which row. For every column in which row there is this blue circle that protects this value, and I want to say this value stays forever, so at the end I will have something like 3 times x is equal to something. And this thing in blue circle is by definition non-zero. Right. Yeah, time to see implementations made by others, including for sure this one. Let's see what CP algorithm says. I will find a new link. This is now checking out Gaussian elimination, implementations by others. Sequential elimination. I will just read the full thing to remember it, but theoretically I could just go here. We'll see later if this is the same with my algorithm. I guess they care about number of solutions different than one. Well, I skipped that part conveniently for me. In general, we want to indeed handle n equal to m. We want to handle cases where height of the grid and width of the grid are different. It is possible to exchange two equations, linear combination of that row and some other rows. This just means, say, row minus equal some other row multiplied by multiplier. Do I use any division multiple times in my code? Ratio is this, then multiplication. All right, this is important. So good thing we don't divide a lot. Division is quite slow compared to other operations like multiplication, and it's good that here I divide once, and then when I go and times this part is bottleneck. This is n cubic, because we have one for loop inside another and inside another. So this gets repeated n cubic times, and we wouldn't want to divide here. Same if we used computations modulo p. You don't want to compute inverse of a number many times, because it's more time consuming to do so. I didn't want to minimize this. I just wanted to get back this. Divide the first row by that. Sure, you can. Maybe I should do it too. Then at the end I will not have 3x equal to 11, I will just have x equal to 11 over 3. Second column of second row. First column of matrix A will consist of 1 on the first row. See, so they very much want to get that diagonal of 1s. If n is equal to m, then A will become identity matrix. That's not true. It's a case only if equations are independent, linearly independent. But if not, then we can get by coincidence some rows equal to 0. So I disagree with this sentence. Find one row of the matrix where the ith column is non-zero and then swap the two rows. Swapping rows is easy to do. Indeed, I think there is no harm in swapping rows. Maybe I should do it too. Instead of keeping this information on which rows were taken, I could just swap them around. Without this heuristic, even for matrices of size about 20, error will be too big and can cause overflow for floating points data types of C++. Indeed. Degenerate cases. I'm interested in that. Do I play video games? Yes, sometimes. General case where n and m are not necessarily equal. Either there is no possible value of variable xi. So system of, what is it? This linear equations? System of linear equations. I would say that this is SLE. Why is it SLAE? What does A stand for? Algebraic? Yeah, indeed. Algebraic. I'm not sure. System of linear algebraic equations. Or xi is an independent variable and can take arbitrary value. Continue the work for subsequent variables and just skip the if column. Remaining untreated equations have at least one non-zero constant term. If you have like 0 times x times 0 times y times 0 times z is equal 5, you cannot satisfy that. You can check by assigning zeros to all independent variables, calculate other variables, then plug into the original SLAE. That's, I guess, good advice. Or is it? Then we need to compare using some epsilon. I think that this is not the best we can do. It's better to just directly check if some row is full of zeros and then the last value is non-zero. Implementation. Returns the number of solutions of the system, 0, 1, or infinity. I am from Poland, Ivan. Where, oh, this is, I think, my which row. For every column, select this. This is the best row for every row, but other than the first few rows, if this is greater than the selected one, then do this. If this is 0, then continue. Swap the two. Because we have vectors, we could just do this with one operation. Swap A of cell and A of row. This is where column, or which row for every column. I had that too in my solution. They compute the ratio, and they do this. They didn't do what they said they are doing. They didn't divide this very row, I believe. Did they? Yeah, if not. Okay, so they didn't. They didn't change 3x equal to 11 into x equal to something. And then fill answer with zeros. For every variable, if where exists, it's not -1, then we do this. I did the same. Then for every row, take the sum, go through everything, check if this sum is equal to the last value, the constant term. If this, then return 0. So I think that this should be done differently. And then if anywhere this variable is arbitrary value, then return infinity. So we have something like 2x plus z is equal 5. Then z can be whatever. And then x you can adjust. Oh, it's not divided as described above. It's not identity matrix. Though apparently dividing the if line can help reducing errors. Can it? I don't think so, but I can try. Do I like the movie Matrix? Yeah, Matrix 1 is, you know, a very well-known movie. I'm going to watch it soon, because I didn't for like 10 years or so. Estimate the complexity. Yeah, this times nm, so it's in cubic. Acceleration. In forward phase, I don't care about speeding up an algorithm twice, it's more that I care about the simplicity. So let's consider this. The current row is only added to the rows after it. As a result, we obtain a triangle matrix instead of diagonal. Alright. So it's about whether we get something like this. Y minus z is 3, z is 5. This is triangle matrix versus something like that. And z is 5, let's say. With this form we already know answers. With this form we need to go backwards and apply z here, then we will get that y is equal to something and continue with that here. So sure, this final phase is fine, but what changes in the forward phase? What changes when we implement stuff? So when I figure out that, the difference is that I don't apply it here above. And so I don't get rid of y here. I don't know if it's easier to understand. We start relying a lot on the order of rows, and I would prefer to avoid that. Maybe I should think how this will look like for binary system to make the two implementations, like ways to explain it, similar. You still wear Santa hat? Oh, on YouTube, right? Yeah, I need to change it. Pivoting is a big deal in Gaussian elimination. Yes, it is. I checked that like half an hour ago, and I got something like for particular values, like values up to 1000 or so. Without that, my code worked only for n up to 20, and with pivoting, it worked up to 200. But I don't think that those articles interest me at all. They describe different kind of algorithms that will be very precise, I think. Because there are various ways to implement Gauss to make it more precise. Not necessarily then it will be cubic. I agree that pivoting is a big deal. All right. So I think that I don't want to introduce the name of triangle matrix. I think I will just stick to saying that. Okay, so here we see y. For now, this is arbitrary. We see y. We use it to get rid of this part here. So we say this minus equal this second equation times 5. And with this we guarantee that this is 0. So I will stick to the fact that after we are done with two columns, I will have here some non-zero, like 3 times x. Then here it's 0 times y. And then here something times z. Say we have this is on purpose 0, and we have y minus z is 3, and what's the thing here? I already got rid of y here, and I got rid of x here, so it's just like 3z is 8. We have this type of form where this is on 0 on purpose. Thanks to that, this is empty, this is empty. This is non-zero on purpose. Actually, this is 1. You can think that this is 1 times y. And those two values are empty. Oh, and finally, we'll look at this, and we use that to get rid of those terms. Yeah, cool. What else? Solving modular. modulo equal to 2, we can perform much more effectively using bitwise operations and bit sets. If A of I column. There's even easier implementation. Okay, so whatever. Oh well, if I need to retrieve it, not just know the base, then indeed we need to do some more implementation, right? I'm now reading about heuristics. All right, I will not talk about this in my lectures. And here they say that we can improve the final solution. I don't know if this helps at all. Also, now that we don't use this, let's see how big value I can deal with. Can I do 200? 500? This is random matrix of size 1000 by 1000 with random values up to 1,000,000. And it seems that I find some answer, and the mistake is this thing. It's quite a good mistake. So for random matrices, this precise Gauss with pivoting works very well. It's always good to avoid epsilons. If anyone wants to do competitive programming while we listen to Erich, we are on binary search. I don't think that that you will be very efficient listening and solving other problems at the same time. But I won't forbid you. That's up to you. All right. What now? There are various problems here at the bottom. Chat, if you have any suggestions here about what I'm doing, then feel free to say that. I will very happily get some feedback and suggestions. Zero, one, or more. So I guess by non-zero here I mean that no variable should be 0. And I will guarantee that such solution exists. It will not be right. No, it's actually easy to do this. Just when you have, it's like when you have x plus y plus z is equal to something, just try to make all byte one variable equal to 1, or 5, 7, something like that, and then you will get some x. If I think it's a good idea, yeah, it will teach people some stuff. Still, n needs to be small. Otherwise, we deal with huge precision issues. Put Matrix soundtrack as a background sound on the upcoming video. I see. I appreciate the idea, but I don't think I will follow on that. Oh, unstable graph was not a stupid problem. Right. Why do I have here something on Matrix Expo? I think I will just remove it. I already covered Matrix Expo. So I'm removing this. Computations model lectures in next 2 weeks. This was written a year ago. I indeed covered this half of stuff. Oh, and I see that I was supposed to talk about expected value in a chain. This might be another lecture indeed. Well, I can just remove that. Any solution where no variable is 0? I think I can guarantee that, right? What can I get? If I get x equal to 0, then it means that there is no other solution, because this is forced. If I get x plus y equal to something, then I won't have y in any other thing. That's not true. Okay, this can happen. X plus z plus w is 7 or whatever, 5, and then y plus twice z minus 3w is 8. Let's say we have this, then z and w I can set to some random values and just hope that y and x, like I can get this as the final form. But it will be fine to just for every non-fixed value set some random value there. At the end, those two are special and they depend on everything else. Now z and w, they are not fixed and can be whatever, but for each of them, if you generate random real value from, let's say, I don't know, from minus 10 to plus 10, you will get some x and some y. And then probability of x or y becoming 0 is very small. Or even you can generate it again if you get some 0. Yeah, I like this. Competitive programming applications of Gaussian elimination. Well, you solve equations. You also can, as I said, it's useful in geometry. You can intersect planes, lines. And we often do Gaussian elimination to deal with binary numbers, but I think it's very artificial that we do that. I would say that matrix exploitation is more common because, as you said, we use it to accelerate dynamic programming. Okay, so this will be a nice non-trivial problem. I'm still not sure about this, but it just seems too easy to just allow people to make those. Yeah, I want them to use values, all values that are in the final matrix. Won't you need 4 equations to get a particular solution? And my point is that it might happen that this is the final matrix, right? In this problem, I don't guarantee that the number of equations and variables is equal. Even this can be given in the input, and then you cannot simplify it. Or if I put arbitrary values in those positions, then you cannot simplify this. It will be just like this. And then, depending on what z and w you generate, you will get some x and y. What is a non-trivial problem? What is life? Non-trivial means not trivial. Trivial means straightforward, I guess. So directed graph random walk is maybe a separate lecture. Shall we start doing stuff in Polygon? Or do I need to do anything more? Now, do I want to here say count solutions? Or solve it? Yeah, I guess count solutions. You will say you need to print 0, 1, or infinity. Let's say 2. Fine. Now, regarding Polygon, I'm a bit afraid of doing anything and showing that to you, because I might, by mistake, show you problems, like other confidential problems. I must be very, very careful, or I could create a new account. On my account, I can create a problem, give access to some dummy account, and on this dummy account will have access only to problems that I can show you. I think that might be a good solution to this issue. I'm on my second monitor, I'm logging in. Polygon always sends an email with confirmation, so maybe it will forbid me from using the same email. That might be bad. Right, new problem, name, Gauss, will change it later. Now, log out, register. So this is what I'm doing right now. I'm just creating a new account. Password. Suggest a random password. All right. I need to confirm email, and then I think we can start. Do you see any disadvantage of the method I'm using? As I said, I have already an account in Polygon, but it has access to a lot of confidential problems. I'm going to there create a problem, give access to my dummy account, and only show you stuff from dummy account. All right, it seems that we're good. This is what we see just after registering to Polygon. There are 3 example problems, but no, today it's not for you a tutorial on creating problems in Polygon. I will just create a problem. And now I need to log back into my main account. And give access. Manage access. Add users. Right access. Log out. Let's see. All right. Ktebowski too got access from Ktebowski. Oh, great. Is it gonna be a short stream today? I don't know. We'll see. Whatever. Like, if I feel like doing this for 5 hours, I will do it for 5 hours. I can hack him. Whom? Me? How? You're given a system of n equations and n variables. Let me use the same style I used for matrix experimentation. Lowercase k. I like to be consistent. Lowercase n, okay. You're given a system of n equations and n variables. It's guaranteed exactly one solution exists. Find it. What's the name? The name is real value Gauss. Gauss. Can I actually say Gauss, or is it just me? Like, can I say Gauss on real values? Or do I need to say Gaussian elimination on real values? Equations with real values. I will spend half an hour now on this. Find it. Let's allow one. No, I need to say that the last value describes the constant factor. Then something like each of the following n lines describes one equation. If there is equation like that, I need to say that there are values 2, 3, minus 7 in the input. Each of the following n lines describes a single equation, or each of n equations is described by a single line containing blah blah blah, some values. refer. Maybe I can even cheat a little bit and say refer to the example. Because it will become obvious if I dare draw in LaTeX what actually the system of equations is. Actually, I need to know how to use LaTeX for that. Yeah, I need something like that. Oh, exactly this. All right. I need this with equal to something. Of course, I will choose a reasonable sample test. Why do we have two minuses here? All right. It would be nice to write something here. Hello, Pruts. Oh, I need to for sure say what are the limits. Contains n+1 values. Say this. They describe a single equation. I shouldn't maybe use x, y, and z, but we'll see how it goes. It would be better to do x1, x2, and x3, and so on. Then we can say there are n variables. Maybe this will be fine. And the limits are -5. Oh, I need to say if they are integers or real values. -10. 10. Maybe like this. Don't expect from this moment onward this stream to be very interesting. I will prepare problems in Polygon. You can watch if you want to see how to use Polygon, I guess. Oh, that's a long maintenance period. Oh, wait. It's right now. Okay, I need to save a lot. Enter n. Each of the following n lines contains n+1 real values. They describe a single equation like that. It's not the worst. Right, output format. And do we print one after another? Print n lines. So Andrew, how are you going to hack me? Palindromic trees, could you please take a look at it? But what do you expect from me now? I know palindromic trees. I see that you linked some long blog, long article. But what now? I could theoretically now spend 15 minutes and go through it and see if I understand this article. I could also now make a 1-hour lecture on palindromic trees, but obviously I will not just switch from what I'm doing right now. Print the solution in n lines. Print values of n variables, 1 per line. And there's some allowed error. Maybe I will make it even bigger, like 10 to minus third. Print values of n variables, 1 per line, allowed relative or absolute error is this. This is not a very formal statement. If it was a code forces round problem, it would need to be more formal, but I don't care. Like here, theoretically, you need to say a of ij. Like the ith of the following n lines, blah, blah, blah. Or do I want to do this? Maybe. Right now it might be confusing because somebody might think that, oh, apparently I have only n+1 numbers. Yeah. The ith following n lines describe equations. No. More at Coder style. Maybe I can do it like at Coder. I will finish this and then consider to make it in at Coder style. The ith of the following n lines contains n+1 real values. ij. Even with at most 3 digits after the decimal. And we need to fix the equation. It doesn't look that bad. Now, should I leave xy or not? Print values of n variables, 1 per line. Now, do I check this for the answer? I will have my own solution. For every printed value, allow this. This will at least be precise that I don't just check if the equation is right. I just check if variables are close enough to my printed variables. Cool. Are you using most commonly rating selecting text and code? I see you deleted a word in the text box here somehow. I don't know. I use mouse a lot actually. So I cannot now tell you what I used a minute ago. I use arrows and keyboard a little bit. Like home button, end to jump to the beginning and end. Sometimes Control and Shift because then you can mark a full word, but not a lot. Should I increase n? I will not increase n because I want to make it easy here to debug this. If your solution fails, I want to show you a test. keyboard, some old Logitech keyboard. Read this. The model is there. Now it's time, I guess, to create some tests, implement a solution. Or do I want to do this in my GitHub repository? That might be a better idea. Do I have code forces directory? I don't. So what? Gauss, code forces, Polygon. Fine, and now I will have multiple problems. I can call them 1, 2, 3, and so on. Real value Gauss. Maybe it should be called real values. Well, it's real value Gauss, whatever. There is this convention that it's not obligatory, but when I work with others in Polygon, so also when I work alone, I keep using that. Let's say that I'm John Smith. Then I name a file JS underscore something, and here I just put information about this code. For one possible name of a file for me would be time limit exceeded and cubic.cpp. Or yes, for me, main solution is usually like this. Some other main solution will be this, like extra logarithm, or some extra information, or just alternative solution, or no hashes, something. Often I put here some short piece of information, and then also precision. Let's say this failed because of precision. I will keep naming files like that. This is why this is kdac.cpp. So we shouldn't really care about pivot that much. You had a code forces directory, did I? Where? Other than this? Oh no. Why? Damn it. Right, what's the better name? I think code forces, because not everybody will know what code CF means. So CF Gauss here. Right. Now, as this, do I already want to have this version with pivots? Sure, let's have that. Do I want to here leave this extra stuff? I don't think so. Let's make this a short, nice code. set precision. Also, I don't compute big. Okay, we have something. Then take this input. None and none. I don't think that's right. Oh, actually this is right, because it's this strange input where there isn't exactly one solution. This, I believe, is supposed to be 0. Minus 0.6. Oh, indeed. So it's just an unusual test where this is 0, but I have an error by 10 to minus 16. Let's change it to something else. Right? I don't need that big precision. Scientific versus fixed matter much? In life, not really. When printing, I believe that systems like Codeforces will not care about it, and you can print this and get accepted. But in various platforms, I don't know. How CP problems are created? There are many articles on this. Sometimes you come up with a problem from real life first, sometimes you come up with solution first. Can I simplify this some more? Greatest pivot. Guaranteed, because there is exactly one solution. No division by 0, because there is a solution. What if there is something like 0 is equal to 0? A validator for this problem will be pain in the ass. Alright, can I improve the format at all? We read the grid A, use the row, which row for every column, every column variable. Keep row where keep its special row. Row with greatest value in this column. Greatest absolute value. Not used, and either this is -1 or this. Cool. Fine. I think this is good enough. I need to here in virtual machine run Polygon. Code versus Gauss, real value, this. Keep up the good work. Thank you, DJ Gerf. We have something, and we will add some test, but in the long run we want it to be different. Now that we add the test, checker not found. Right, checker, single or more double, max error 10 to minus fourth. And I will put multiple sample tests eventually. Why is it so slow? No, maybe Polygon stopped working, or my internet stopped working. Be right back. Hooray! And I think Polygon has just stopped working. Yep. Hopefully it's all saved. I mean, main of my work was doing research and implementing solutions, so I have that. Statement possibly will be lost, but I can just rewind my stream and rewrite it in 2 minutes. Not a big deal. I should have copy-pasted everything in the statement. Maybe I have it somewhere here. Right, actually I have this on my other monitor. It's I mean, it's not that I can hear copy latte, but it's already not that bad. Actually, I added some more stuff, right? No, this is kind of the final version, other than the test. So it's not all lost. But it seems that Polygon and Mike, they don't want to let me make this stream longer. If that's the case, then I think it's time to finish the stream. Let's do some speed racing, and then we can call it a day. Does code versus work? Nope. There is this. Yeah, there is maintenance message. All right then. Try refreshing. Sure, I can try. But they warned that there will be maintenance. Yeah. I guess I can then close that. Go on Time Machine and open old website. Yeah, I will do that with Polygon and my password. Right, where could we race? Type Racer? Here you go, chat. Oh, I'm not logged in. Oh. Okay, I am logged in. 95 words per minute. Guest, congratulations. Country, Canada. Netherlands. Philippines. United Kingdom. Germany. Why is everybody... Normally 50% of my audience is from India, so I'm surprised by those countries, unless all of you are using VPN. I forget the name. Which paint do you use? I don't know. Microsoft Paint. If you're asking about my software for drawing, it's OneNote. Belgium is going strong. We have the first person from India. Instant dev mode. Cool. The races will be a bit faster if the first wrong character is game over. The program is OneNote, the one for drawing, but it's not the best. In particular, it doesn't understand how strong I put my pen on a tablet. So, but it has some advantages. Late into the night I write, and the pages of my notebook, blah blah blah. I would have a very nice score if I didn't mess up the middle of a first line. I would have 120 or so. My top score is 122 words per minute, so it would be close to that, maybe 118 or so. Fifth. Yeah, congrats to Jabra for winning. Best race 138, average last 10 races 101. Actually, I have the similar average speed, but my best is much worse. Races completed more than 1,000. I practiced a lot around 5 years ago when I started typing with 10 fingers without looking at the keyboard. Sandro is very strong. Average 93. So Jork is stronger, it seems. English is quite fast to type. I agree. English is something quite easy to type. I'm much slower in Polish. No, the more you type something like English or code, the faster you will be there. I cannot type in Polish faster than in English because every day I don't type in Polish more. Also, Polish is harder language. Damn it. Short text, big variance. I can try again here. I cannot open it in new tab. Can't. Leave and enter. Are you sure? Not really. I can maybe in Ubuntu, if I have it, I can run TypeRacer. Oh no, I will do 10 fast fingers later, and I will show you how I type in Polish. But Polish has special characters, so you need to be slower. And I believe that QWERTY keyboard, or just any keyboard out there, is better for English than for Polish because of just character frequencies. Right pinky in typing. You know, right pinky is very important for coding. Like all the characters like brackets are there, plus, minus, equal. No. Drawer consistently winning. What I'm very happy about is that I adjusted my pinkies for using shift, because it's normally recommended in those systems for fast typing that I think you use only one shift, or maybe you use right shift when you need to type some character in left hand, and you use left shift when you need some character to type something with the right hand. But my right pinky is very busy with special characters encoding. So what I do is I use left pinky for almost all characters and digits, because otherwise left pinky doesn't have anything to do. And the exception are 1 QAZ, because QAZ are on the very left, and then I use right pinky for that. Or I would need to shift my whole hand, because A, like left pinky types A, but it cannot type A and left shift at the same time. Yeah, I use left key. I use right pinky for keys around plus. P semicolon colon, some slashes, brackets, 0 minus plus equal underscore. All of that is right pinky. Okay, one more and then I will do something else like Polish test or coding test. Maybe Polygon is back, but I don't think so. A few more minutes and then end of the stream. Three, two, one. I've walked down the street before, but the pavement always stayed beneath my feet before. All at once, I'm several stories high, knowing I am on the street where you live. Right? Guest one, guest from United Kingdom. Polish giant. I don't think I'm 7 foot tall. What is 7 feet in centimeters? No. I think it's more like 6.5, right? Yeah, not even that. 6.3 or so. All right, let's try Polish. I need to log in. Test pisania. Let's go. 106, but I don't know. So I would say that on average I should get around this with simple Polish words and around 110, maybe 115 with simple English words. But when you introduce harder Polish words, I believe that's harder, just because of special characters. Keyboard different? No, I have a standard US layout. Yes, Polish is similar to Czech. Can you read while writing? It would slow me down, and I try to enforce a rule that in the chat you should say only things in English, so also maybe I shouldn't speak non-English. Alright, well, last thing to do. Okay, that was a bad start. And this was with a lot of mistakes. So 120, I don't know, maybe if I try to be a little bit slower, but make fewer mistakes, maybe I would get a little bit more on average. Typing's GG, what is that? $133. Here we go. But here I was lucky. I don't think I made a single mistake. Typing at my reading speed. Once you have muscle memory, that is like, what's the difference? So I think with this we should finish the stream on high end. Quit typing, you will lose your speed. If I don't type for a few years, then sure, but if I just make a break of 1 month, I will not lose much speed. Command backspace to delete the whole word. So cornfield, I think your advice is good and I would be faster this way. But actually it's a real world thing, right? Like if I type, let's say 1, 2, 3 and control backspace, yeah, controls backspace removes the whole word. So it would be more important to actually learn to do it in real world, but it's hard to switch after so many years of typing one way. If then you get to know, oh, control is very special character. If you do control arrow, you move between words. Control backspace, you remove full words. It's very hard to start using that. No, I'm not on Instagram. All right. I should have, by the way, put this stream on Codeforces because it's related to Codeforces. Well, I need to remember next time. Let's visit Twitch. Somebody doing programming, maybe? I mean, programming related to what I did. Time to clash coding game.
easy to optimize. Yeah, that's understandable, Woody.
I think that's a fine rate to make. OnlyFans? Not yet. You don't deserve it. Yeah, I should now set some crazy goal, like, 10 million YouTube subscribers and then OnlyFans. Right. How do I rate on Twitch? Rate channel name. All right, this will work. So thank you everybody for watching. See you next time, most likely on Thursday, some coding interview problems, but also I will do more streams like this one where I will prepare this Gaussian elimination lecture. All right, bye bye.